Hello everyone, welcome to this lesson. So in this lesson we're going to do a normal kind of question that we've always done, and then I'm going to show you, so I'm first going to do it the way that we've always done it, and then I'm going to show you a formula that you could use instead. So we know that this 5 kilogram ball starts from rest and rolls, and obviously it's going to get to point B. Now because there's friction, it's going to lose some of its energy along the way. And so it won't reach a height of 8 meters, it will be a little bit less. So as always, we're going to work out the mechanical energy of the object at A, and so we know that mechanical energy is the following. And because the object's at rest, it has no kinetic energy, and so we just need to use potential energy, which is equal to the following. And so the potential energy is going to be equal to the mass, which is a 5 kg ball, times by 9.8, times by the height, which is 8, and that gives you a value of 392 joules. So at A it's got 392 joules of energy. Then it's going to lose some of that energy due to friction, and so we can work out that energy loss because we know that energy is work, and so we can use the work formula. And so that's going to give us a force of friction of 4. The distance of the slope they've told us is 10 meters. And remember, friction always goes opposite to the direction of motion, and so when the ball is here, it will be 180. Even when the ball is here, it'll be 180, and when the ball is here, it'll still be 180. So we can say cos 180, and that's going to give us negative 40 joules. So the object is going to lose 40 joules of energy. It has 392 joules at the beginning, so if you minus 40, it means that at B it would have 352 joules of energy. And so at point B, that's the highest point that it would reach. We know that its mechanical energy is 352 because it started with 392, it lost 40, and so whatever's left over is 352. At its highest point, it won't have any kinetic energy, and so if we look at its mechanical energy, we know that it should equal 352, and that's equal to its potential energy plus its kinetic. But there is no kinetic, and so it's only potential. And so we can say 352 is equal to mgh, which is 5 times 9.8 times height. And so you can then go calculate the height, and the height that it would reach is 7.18 meters. So that makes sense. It came from a height of 8, loses a bit of energy, and so it only reaches 7.18 meters. If there was no friction, it would keep reaching 8 meters the whole time. Now I'm going to show you how to do this using a formula. I've seen this formula used in both the CAPS as well as the IEB curriculum. However, the IEB curriculum does not have it on the formula sheet, whereas the CAPS curriculum does. So this formula is the following. And so this formula does everything in one step instead of breaking it up into smaller steps. Let me explain. So change in EP, that's the potential energy. Change in EK, that's the kinetic energy. WNC stands for the work, and then the NC is the subscript, and that's just for non-conservative. Now remember our first lesson on mechanical energy, we said that non-conservative were forces such as friction, applied, and then air resistance, but we don't look at air resistance in grade 12. And so it's just these two. If you ever want to use this formula, so this is the mechanical energy formula. You can use it for any of these types of questions. If there is no friction or applied force, you just make this 0. Okay, and then you just go use the formula like that. It'll take care of everything for you. And so in our question there is friction. Now we're not going to put a 4 over here because that's newtons. This is work. So we have to use the formula for work, which is this over here. And so I'm going to put this here on the left hand side. So the force is 4. The path length is going to be 10. And then for friction it's always cos 180. And then we make that equal to the change. So this is the change. So it's mgh final minus mgh initial. Then you've got plus, so I'm going to say plus over here. Then it's the change in the kinetic, so it's half mv squared final minus half mv squared initial. Okay, now we just go fill everything in. So it's 4 times 10 times cos 180 equals to mgh final. So the mass is 5, gravity is 9.8, but we don't know the final height, so we just say hf minus. Then we've got everything from the beginning, so that's 5 times 9.8, and the initial height was 8. Then we say plus. Now the final velocity is 0, so our kinetic energy final is going to be 0, but let's just fill everything in anyways. That's going to be 0, and our initial is also 0. And so these two fall away. That won't always happen. And so all that we need to find now is HF. And so if you had to go work this out, you're going to get negative 40 over here. And remember that 40 was the energy that we lost in the previous method. Then 5 times 9.8 is 49, h minus, and then this part here is probably going to be the 392 that we got earlier. Yep, 392. You see, so this formula just does it all in one. And then if you had to go solve for h, you would end up with an answer of 7.18 meters. And so this formula does everything in one step. You can choose to use that, or you can do it the way that we've been doing it, where we do it in separate parts. So guys, that's the end of this lesson. Thank you very much for watching.